In this video, we're going to talk about values of sine, cosine, and tangent using the unit circle. All right, so in one of the Google forums, someone mentioned I'm not sure why we're learning the unit circle, why the unit circle is important. This is basically why the unit circle is important, because it helps you find values of sine and cosine. So if you're trying to do things with sine and cosine, you want to know what the values are if you're trying to do SOHCAHTOA and stuff like that. So that's the whole point of the unit circle. It just allows you to find values for these functions that represent angles. Most of the time in most applications, you're not going to have a nice perfect 30 degree angle or 45 degree angle. So a lot of times you will use a calculator. But for anything that we want to try to solve by hand, being able to figure out these sine and cosine values, the kind of most straightforward way is using the unit circle. So that's why we spend all the time to learn the unit circle, and it makes the definition of sine and cosine a little bit easier. And then what is the definition? So once we have the unit circle memorized, the cosine of whatever angle we care about is just the x value on that circle at the right angle, the correct angle, not the right angle. The sine of an angle is just the y value of that angle. And then we learn the tangent of an angle is just you take the sine of the angle and divide it by the cosine angle. So again, this is just a definition. We verified it with SOHCAHTOA, but tangent is just the definition is sine divided by cosine. All right, so how do we find sine of 7 pi over 3? All right, well, we want to use our unit circle, but right away, if you look around at 7 pi over 3, you'll see it's not on here. So the other thing we have to remember, the only extra thing we have to remember is we have these things called coterminal angles, which are angles that are going to look the same on the unit circle, which means they'll hit the same value, which means they'll have the same sine and cosine. So how do we find coterminal angles? As long as we start at an angle and do a full circle, we end up back at the same place. And we're talking about radians. A full circle is, it's actually not written here, is 2 pi. All right, so I can take 7 pi over 3, and then go a whole circle backwards to get a smaller angle that looks the same. All right, so how do we do this? All right, with radians, it's a little bit harder than degrees. Degrees, you just subtract 360. Radians, I have to make sure I get the bottoms to be the same because there's fractions involved. So I'm going to make this a fraction. I want them both to be 3 on the bottom, so I have to multiply this by 3 over 3. And now I can subtract and get pi over 3. So it turns out that this angle, pi over 3, let's make it color you can actually see, pi over 3, is the same as 7 pi over 3. They would both kind of be this line going out. And the sine, we take the y value, which is the square root of 3 over 2. All right, what about cosine? Negative 7 pi over 6. We run into the same issue. Negative, there's no negative angles in here, so we can't find negative 7 pi over 6. So we use coterminal angles. In this case, we have a negative angle. We want to turn it into a positive angle. So instead of subtracting 2 pi, we're going to add a full circle, 2 pi. We do the same process. We can always make something a fraction by putting it over 1. And I want the bottoms to be 6, so I'm going to multiply by 6 over 6. Negative 7 plus 12 is positive 5. And we get 5 pi over 6. So cosine, or negative 7 pi over 6 is the same as 5 pi over 6. Cosine is the x value, negative square root of 3 over 2. All right, here's one for you to try on your own. Find the sine of 15 pi over 4. I'll show you the answer in 3, 2, 1. All right, and this one's very similar to the other ones. It's 15 pi over 4, too big. Subtract 2 pi, you get 7 pi over 4. Take that y value, negative square root of 2 over 2. All right, now we also want to do the tangent. But the tangent is pretty much the same process we're doing with sine and cosine, just one extra simplifying step. All right, so tangent is just the sine of this angle over the cosine of this angle. Sine of 2 pi over 3 is square root of 3 over 2. Cosine is negative 1/2. All right, so that's technically right, but obviously that's fully simplified because you have fractions inside of fractions. So we have to remember that if we're dividing by a fraction, that's the same thing as we keep the first fraction, change division to multiplication, then we're going to flip the second fraction. So flip -1/2 to -2/1. You can put the negative wherever you want. In this case, the 2's cancel, and we get -√3/1. Anything over 1, we can kind of just get rid of the fraction and make it -√3. Right? So just remembering this simplifying step of changing it to multiplication, keep, change, flip will help you get the most simple answer. All right, same thing, tangent is 7π/6. We put the sine of this angle on the top, so 7π/6 is here. The sine is -1/2. The cosine is the -√3/2. All right, we remember that this is keep, change, flip, so we keep the -1/2, change the multiplication, flip to -2/3. Here, the 2's cancel, the negatives also cancel, and we get 1/3. And this is one of those times where if you put this in a calculator, it's exactly equal to if you put this in a calculator. These are the same thing. This is the right answer. But it's not fully simplified. We have a rule that we're not supposed to have square roots in the bottom of a fraction. All right, this is one rule that even as a doctor of math, I'm not really sure why it exists. But it's a rule, so we're going to follow it. We want to get rid of this square root in the bottom. So the way we fix that is we multiply by the same square root. And because we're multiplying, we have to multiply the top and bottom by the same thing. All right, so why is this useful? Well, the top, 1 times anything is just that thing. But we do this because on the bottom, when you multiply square roots together, that's the same as squaring it. And square roots and squares are opposites, so it just becomes 3. So we fix that issue of the square root being on the bottom, and this would be the fully simplified answer I'd be looking for on skill check or test. All right, but here's one for you to try on your own, tangent of π/4. All right, so go ahead and try that one, and I'll show you the answer in 3, 2, 1. All right, the answer is just 1. Sine is square root of 2/2. Cosine is square root of 2/2. When you make it a fraction, they cancel. You get 1. All right, so most important thing, cosine is x values, sine is y values. And for tangent, whenever you have a over 6 angle for your tangent, you're going to have to do that little trick we saw. Actually, let's just go back to it real quick. Of rationalizing the denominator, making sure the denominator is a number of this little thing here. So whenever the over 6 is there, you're going to have to do something like that. All right, and the only thing I don't have on this slide is remember coterminal angles. I can always add or subtract 2π to an angle, and I'm not going to change its sine or cosine because I'm doing a full revolution of the circle.